Hi everybody, in this video we're going to be taking a close look at programming an engine hour run timer, or basically a timer that accumulates the number of hours that an engine has been actually running for. So not to be confused with the typical countdown timer that we use on most models to mainly give us an idea of how many more minutes our battery's going to last for, or how much fuel we've got in our fuel tank, that sort of timer. This particular model I've got here is an Extra 330. It's a 35cc model. It does have a timer that I've programmed up for 8 minutes. So this is my normal flight timer. So I'll fly for 8 minutes. As this counts down while the plane is flying, when it gets to zero, or just before it gets to zero, I get various voice announcements and beeps to basically give me an idea of how much fuel I've got left in the actual model. Now, I think most of us are very familiar with these countdown timers. I do have an earlier video with a couple of good examples on how to set these up. Obviously, you can have multiple voice alerts and all that sort of stuff. However, an engine hour run timer is a little bit different. So in this particular instance, we want a timer that counts up, so it basically logs accumulated hours. So it'll give us an idea of how many hours the engine's been running for. So typically for an internal combustion type engine, we want to have an idea of how long it's been running for, how much work it's done, so we can then schedule various maintenance activities. So for instance, with my Sato 4-strokes, Sato recommend that every hour that you have a look at the valve clearances and adjust the valves if need be. And that interval is set by the manufacturer at around 60 minutes or every hour. That'll vary a little bit depending on how much work the motor's done, because it tends to settle in after a few hours. But, to have an idea of how many hours your engine's been running for, you either have to keep a log of the number of flights, which is not necessarily that accurate, because you might be in the pits, you might have the engine sitting there idling in the pits for half an hour before you go take off, and you might record, say, one flight, but the engine might have been actually running for, say, 20 minutes, while the flight only took, say, 10 minutes, because it was idling in the pits. So ideally, you want a better way of, taking note or accumulating the number of hours that an engine's actually been running for. So what do we need to accomplish this? What do we need? We need some way of determining when the engine is running or not. So one of the best ways these days is to have a telemetry sensor which senses the engine RPM. So in this particular model, I've got a Spark Switch RS. And that has a facility in combination with the DA35 that I got fitted in this particular model. We'll take a look at it in a sec. I have an RPM measurement. So normally the RPM and measurement appears up here when the engine is running. Of course, at the moment, I'm just in my garage. The engine's not actually running, otherwise you'd hear it in the background. But when the engine's running, I get a RPM reading up here in this top screen. From the telemetry, that's a feature of the Spark Switch RS, and we'll use that to trigger a count up timer, and I'll show you how to do that. It's pretty easy, but I just thought I'd make a short video. Alright, just before we move on to the programming side of things, let's have a quick look at the model and just see the just a rough setup of the wiring and whatever, to see how Spark Switch RS picks up or how we pick up the RPM signal off the actual engine. So this is my little DA35cc 2-stroke petrol, or as the Americans say, gas motor. Has a electronic ignition. The ignition picks up the crankshaft speed or crankshaft rotation by using a couple of magnets on the prop hub. So there's one there, as I rotate it around, there's another 2 magnets there. So in total 3 magnets. This motor uses 3 magnets so it can determine the direction of rotation to make it safe to start. So basically it doesn't backfire when you're trying to start it. So it's actually quite safe to start with your hands. There's a Hall effect sensor mounted here which detects the magnets. So that detects the magnetic field as the magnets go past, and then basically the ignition fires the spark plug when it's at the correct point in time in regards to the crankshaft rotation. So basically there's an RPM output out of here, but how do we get that to my core? So to get it to the core, in this particular example, I use a PowerBox RPM probe. So the RPM probe basically sits across the Hall effect sensor. So it's basically wire-leaded into the Hall effect sensor cables. And as the magnets swing past, the RPM probe basically neatens up the signal into a nicer square wave. And that then gets fed back into my spark switch RS, which is just mounted in there, just behind the firewall. And then that sends it back into the system and it's received by the transmitter and displayed as an RPM signal. So yeah, that's how we get the RPM from a petrol engine using an ignition system back to the core. Now the DA35 engines, because they use a Hall effect sensor in a special configuration, we are required to use the RPM probe. Some other motors have like a tacho output or an RPM output, and you don't need to use the RPM probe. But in some instances like this, with the DA engines, you need to use the RPM probe to get your RPM signal before you feed it into the spark switch RS. All right, let's head back to my transmitter screen. Okay, now that we've had a quick look at the engine setup, let's have a look at some programming. Actually, just before I jump into the programming side of things, with the engine hour run timer, it's not something you need displayed on the screen all the time, because it's something that you might refer to once in a while. So, I mean, you can, if you want, you can have a widget for it, a dedicated widget for it. But what I've done, this might be handy for some people as well, so I'll just show you what's achievable on the core here, is in the bottom left-hand corner here, I've got my normal flight timer, standard countdown 8 minutes. And you can also have multiple timers in this same location that are running but not actually visible. So in my normal day-to-day, if I go take the model out, go for a fly, I don't really need to know how many hours my engines run. I might refer to it later in the, when I'm at home, every now and then in the field. So I don't really need it displayed on the screen. This is my main screen for this particular model. I have another secondary screen as well, which has all my RF sort of parameters. Obviously all these parameters are logged. But back on the main screen, I've got things like my battery capacity, battery voltage, current for my servos. I've got a cylinder head temperature probe as well, just for general sort of reference. The main one here is the RPM reading, of course. And the critical one here is if I've got any holds or lost frames. So at the end of the flight, I can quickly review these. But the timer here, what we can do is if I just hold my stylus on here, wait for the icons to wiggle, hit it again, I can select from different timers. So you'll notice one down here is called DA35 runtime. So DA35 is the engine, of course. If I highlight that, click on OK, you'll see now that widget, instead of having the countdown timer, this is my engine hour run timer for this particular model. So I can quickly see, okay, this engine's done about 55 minutes and 50 seconds of running. I think the maximum is about 500 hours. So yeah, you can sort of count up to quite a few hours before it needs to be reset or before it goes back to zero. So if I need to look at the number of hours that my engine's been running for, I can just quickly change the widget just like I did then in that example. So again, typically when I'm actually at the field, I'll just display this normal flight timer. Click on OK. And that's just my normal 8-minute, fuel indication sort of timer. And that's the one that I normally refer to on a day-to-day basis when I'm flying. And if I want to, I want to refer to the number of engine hours that my engine's running, I can quickly just toggle over to the other timer as required. That's just a handy little thing that it's just my own personal preference. Like I said, you can make this own, like another widget on the screen, on another screen, or whatever you like, depending on how you've got your screen set up. So that's just a personal preference. Just something that you can do. You can just leave the timer in the background. The timer will still run fine. It's just that you don't need to view it every single flight because it may be of no interest. Because like I said, you might only want to refer to it every now and then. Okay, let's have a look how it's being programmed. So what I'll do is I'll bring the timer to the foreground so we can see it. It's currently set. This plane's actually fairly new. I only maiden it a couple of weeks ago. And being winter over here, we haven't had a chance to do too much flying. So I've only accumulated, almost 1 hour on this particular engine. All right, telemetry. Obviously, we need telemetry to measure RPM. So if we have a look at, say, the telemetry widget, or telemetry controls, I should say. So we go into the little icon here, telemetry controls. And you'll notice here, I've renamed it the sensor and I've put a name here, DA35 run hours, just so later on in the timer programming, we refer to it, this particular sensor as DA35 run hours. The source is the actual spark switch RS RPM sensor. Again, I've renamed it to DA35. So click on OK. Let's have a look at the actual control programming. Now, those of you that have used telemetry control should be fairly familiar with this. We normally have a limiter here. So basically the RPM, in this particular example, I've set a limit of 504.99. So what does that mean? Well, basically what that means is if the RPM is below 499 RPM, or 499 and below, the output is basically minus 100. If it goes to 500 or higher, this value will change. And we can simulate that. So luckily on the PowerBox core programming, we have a simulation tool here. So I can actually highlight that and I can pretend we're actually running the motor, even though we're not running it. So I can actually increase this value. So if you look carefully, I get to 480 RPM, 490 RPM, I increment it by 1 now. Let's go to 499. So I'm doing 499 RPM. However, this hasn't changed yet, but watch what happens when I go to above 499. So I go to 500. Notice that green highlighted green line's now gone up. And this value's changed to plus 100%. So if I go down 1 RPM, so back to 499, notice that's minus 100. Go to 500, it's plus 100. And of course I can go higher and that'll just stay at plus 100. So you can imagine that's just like servo travel, plus 100% servo travel. So what this does is when we get to 500 RPM, the servo output, or basically the output here, goes from minus 100% to plus 100%. So it's like a toggling switch. So any RPM that's above 499, so 500 and higher, will trigger this to positive 100%. And later on, we're going to use that to trigger the timer. So what that achieves is basically if we don't have the engine running, so it's basically doing less than 500 RPM, the timer will not count up. So for instance, when we're starting it, you might flip the prop with your hand. It won't count. However, when it fires, generally the motor will be doing a lot higher than 500 RPM. And basically the timer will then start counting. If the engine stops for whatever reason, the timer will then stop. And you'll see how we set that up in a minute. But just to show you, so at the moment I've got the simulator running at 460. If I click on OK, go back to the home screen, you'll see, remember this was 55.50, I think it was. Now it's gone up a little bit because I was playing around with that simulation. So I go back into that simulation again. Telemetry controls, into the actual control. Let's bump this up to say, I don't know, 591 RPM. So this output's gone to plus 100. And oops, it's a bit too quick there. Actually, just before I do that, just make a mental note, 56 minutes and 50 seconds. Let's go back into Telemetry Controls and turn this on. So we'll just give it a few seconds. And if I go back to the home screen now, you'll see now it's reading 57 minutes and 1 second. Because while we were in that telemetry control screen when I had the simulation, pretending it was doing more than 500 RPM, this counter was actually counting. So once you get out of that telemetry control screen, the simulation ends, so we can't sort of show you, unless the engine was running, I can't sort of show you to it in real time, but you get the idea anyway. Okay, so once you've set the telemetry control, so we've got our on-off basically from if the engine's doing less than 500 RPM, we have negative 100% on that telemetry control. If it's doing above 499, so if it's doing 500 or higher RPM, that telemetry control shifts to positive 100% output. So now all you need to do is set up a timer. Let's have a look at this timer because this is our engine hour run timer, and let's have a look how we've programmed it. So this is actually quite simple. I've called the timer DA35 runtime, nothing too crazy. I started at 0, so if you have a brand new engine out of the box, it'll start at 0. We have a stop time here at 500 hours, or 499 hours, 59 minutes and 59 seconds. I think the engine will probably be dead by the time it runs that many hours. We'll probably need at least 1 or 2 rebuilds. Now, one important thing to make a note of is this auto reset. So you've got to make sure this is set to off. So what's auto reset do? Well, basically auto reset means that every time you enter the model, so if you turn on the transmitter and start them, go into that model, or if you swap models and go back to it, if this is set to on, what happens is the timer gets reset back to 0 every time you start. So that's a handy feature for using a normal flight timer, where you want it to start at the, say in this case, my normal flight timer is set to 8 minutes. So every time I enter the model, the timer's going to count down from 8 minutes. However, because this is an accumulative timer, we don't want it to reset every time we stop the model and go to another model and then come back. We want it just to accumulate the number of hours this particular engine is running. So we have to set this to off. So when it's set to off, if you've been flying for 10 hours and you swap models, then come back to the same model, the timer will start at the 10-hour mark and then keep accumulating time. Now, start and stop for the timer. You notice there's no reset. So I don't really want to accidentally reset this timer in any way. So I've left the reset blank. So with the reset blank, the timer can't be reset unless I come in here and temporarily assign a switch or whatever to reset it. That's the only way you'll reset it. Or if I set this to on and then go back in and out of the model. So that sort of prevents me from accidentally resetting the counter. I have to sort of, manually come in here, program a switch, reset it, and then disable it again. It's just a foolproof method of not accidentally switching or resetting the timer. So we have a start and stop value. So really, this is pretty simple for most of us. So this DA35 run hours, remember this is the telemetry control. So basically the telemetry control is going from minus 100 to positive 100 when the engine's running. And obviously the reverse is true when it goes the other way. So all I've done here for the start is you'll notice the cursor's on the far left-hand side here, the little white vertical line. And at the moment, this is for starting the timer. This particular control is off. However, when we get to 500 RPM, this will go to positive 100, which means this will actually move over to the far right-hand side in the green. And because it'll be in the green, it'll activate the start and the timer will start. It'll start counting up. And then the reverse is true for the stop function. So for the stop control, we're using the same telemetry control, But basically I have the logic inverted. So at the moment, the engine's not running. I've got 0 RPM. So therefore the cursor's in the green over here. And then when the engine's running, it's in the opposite end in the red. So all we're doing is inverting the logic between these two functions, between the start and stop function. And that's pretty much it. Now the other thing is you can also add audio alerts. So for instance, you might have, I was thinking not so much for my DA, but for my Sato engines which need valve adjustments every hour, you could put in an audio alert at say the 60-minute mark, and you might have it repeating say once every couple of minutes, or just have a one-off audio alert. And you could say something like, you know, maintenance interval due. So it'll be just as annoying as those alerts you have in your motor vehicle that say you have to go get your engine serviced or your car serviced so the dealer can make some money. It'll be just as annoying as that. But you can do it if you want to. I haven't bothered with this particular model, but maybe on my Satos I might add some sort of alert there. Just like a preemptive warning. Easy enough to do. All right. Well, that's about it. Hope you learned something a little bit from this video, and hope to catch you soon on another video. Catch you all later.